Let's understand the OLAP mode comparisons. Let's focus on the differences. Let's see the differences between the two different modes. Yes, the first and foremost one is about security. Let's understand. Yes, from the earlier classes back to our SSMS, we learned how to define roles in tabular mode. We did it in the previous classes. How to define roles in the tabular mode. Okay, so here it is one of the examples we learned earlier. DAX, like for example in Visual Studio we have right click, new role. Yes, in DAX expressions we learned it. For example, role for admin, full control, something like this. We add members to the role as well. Like for example, valid Windows user to the role. For admin access. If it is for individual cell access, for example, cube access, we say read role, members, check names. Then comes row filter. Yes, we had DAX filters over here. For example, equal to, say, time underscore data of calendar year equal to 2002. Only 2002 data is accessible to members of this role. So this way we defined roles in the earlier classes for tabular mode. Whereas for multidimensional mode, what we did, we created roles using MDX. And there the options are different. Cube, cell data, dimensions, dimension data. We did those roles in our chapter pertaining to OLAP deployments. So multi-dimensional mode and tabular mode, security items are different. The way we implement security is different. Another big difference between these modes, something called lazy aggregations. For example, here you go. You would like to audit the cube uses. Your requirement to implement 100% aggregations. You remember in multi-dimensional mode, aggregations chapter, when we talk about aggregations, partitions and storage modes chapter, there we learned 30% aggregations. Now you would like to have 100% aggregations. Then what we do, let's see. Let's go for a dedicated audit database. Right click database, OLAP, audit DB. Give one database like this. Give one database like this. Next. Once we get the database ready, the OLAP audit database, next. Right click server properties, multidimensional. This 100% aggregation is for multidimensional. Here we go. Go to general page. Then query log table and connection string, this one. Click on connection string. Provide the server name. Get database engine. This OLAP audit database. OLAP log sample. So 1 out of 10 queries get audited, 10% or 10 out of 100. Queries will be audited where one table called OLAP query log table will be created in this database. Just now you gave one database. To that database, one table will be created to audit MDX queries. Let's see. Go to the audit database. Go to tables and let's refresh. And initially, no additional tables are available. But once we start accessing the cube, once we start reading the cube, the table would be available for auditing the MDX queries. Come on, let's understand the data access. We'll do it carefully. Okay, so here we go. All we do is, remember what we did so far just now. We understood how to just enable audit, right? We just enabled audit. Now go to the OLAP database. Go to Cube Browse. Go to Cube and browse. For example, see here, sales amount, tax amount like this. You do some audit activities in this or do some reporting activities like this. Click to execute the queries. Every time I drag and drop, I click to execute the query. I'm executing few queries and accordingly the audit report is available in this audit database. Refresh, tables. Let's wait for a few moments. One system table called OLAP table will be created. Let's wait for a few moments. One table called system table would be created. Still yet to get it on the screen. Let's verify it again. What we did, right click server properties. Yeah, this one, query log to be true. This is create query log table should be true. Okay, this one should be true. Only then the log table would be created. Click OK. Drag and drop few operations. Refresh. That create query log table is true, right? See here the table is created. Drag and drop Then, for example, something like this. These queries get audited, something like this. The queries get audited. Now, right click, test it. Select top 1000 rows this way. Remember, we are auditing, monitoring the queries. The sample data gets audited like this. You use more queries getting audited, more sample data. Now, how to use it? If you remember the multi-dimensional cube design, we understood something called aggregations. There we got 30% aggregation. Now it is 100% aggregation. Go to partition, usage based optimization, this one. Usage based optimization. Next, establish a connection to the source, Windows authentication or SQL, any valid authentication is fine. Establish connection to the data source, your regular database engine, queries, and count. Click next. Say performance gain reaches 100% and start. Hit finish. So create new aggregation. And hit finish like this. What we are doing here, instead of going for 30% aggregation, now we are going for 100% aggregation. That is called usage based optimization. We are auditing the usage from OLAP query log system auto generated table. From there we generate aggregations. Whenever you go for usage based optimization, multi-dimensional mode OLAP database partition properties, go to partition properties. Here we need to have the processing mode as lazy aggregation. This one, it should be lazy aggregation, meaning processing first, aggregations next. Processing first, aggregations next. That is called lazy aggregations. It's a recommended practice. So this is one major difference. No tabular mode, when tabular mode cannot support this usage based optimizations and lazy aggregation. Other major difference, in multi-dimensional mode, you right click and new query MDX. We can do something called cube write back, meaning we can update a cube. For example, update cube name set. For example, sale amount for a particular year and a particular quarter. Say 2003 quarter 2. For that quarter, let's have month. For example, I'll say second quarter, So first quarter, Jan, Feb, March. Second, April, May, June. Let's go for the June quarter. Inside June, for example, we have date. Here we go. This is a format. So 2003. Then June month. I'll take, for example, 6th day, like this. This is the slice of the cube, particular slice or the cell of the cube equal to. We can begin a transaction, update the cube, and commit transaction. This is an MDX query. Generally, in real world, for updating the forecast values or any other kind of expected value, we can do this kind of updates. So begin transaction, update, sorry, this one. First you have to say begin transaction, okay, one at a time. We need to do one at a time. Begin transaction, then we need to say update. First begin transaction, then we have to say update cube set this way. This is the process. Click update. This would take time to update the cube. It's going on. It will take some time to update the cube. After the cube is updated, let's wait for a few moments. Then finally, we are supposed to commit. This update would take some time. But make sure the year, quarter, month, day, they should match a particular cell. This is the format. Finally, commit. Generally, we say commit. If you don't want to commit, then you say rollback. This would take some time, but this is called write backs. We call cube write backs. Means you are writing the content back to cube. Whereas in tabular mode, you don't see that kind of operation. Update will be complete in next few moments. Then we say commit. This is called write backs, cube write backs we call. Whereas in regular tabular mode, we don't see those changes. We don't see those options. So here it is, security differences, cube audit and write back with lazy aggregations, and usage based optimization. I'll take this complete query for your practice purpose. Next, we'll say commit transaction this way. Exclusively in multidimensional mode, we have some dimension types, SSAS dimension types. From the older classes, we learned database dimensions, dimensions pertaining to the entities, right? The older classes, we learned it in modeling, dimension modeling chapter. We got cube dimensions pertaining to relation. So entities yield database dimensions, relations yield cube dimensions, right? This one. Here we go. For example, here you see measure group dimensions. These are database dimensions. Whereas here it is, these are the cube dimensions. Fact dimension, meaning a dimension is both a measure group as well as a dimension both. We have time dimensions. The other day we got time calculations, year-on-year sales, or by say year to date, month to date, etc. Same way we have other one, regular dimension. Whatever dimensions we practiced all these days, they are regular dimensions. Database dimension directly related to a measure group. Direct relation like customer, product, sales, etc. There is something called reference dimension, a database dimension indirectly related to measure group. So A to B, B to C, that is called reference dimension. A to B, B to C, like this. Then we have role playing dimension. The database dimensions result in additional cube dimensions. Like for example, time data in our earlier examples, the time data is resolving to due date, order date, ship date. That is called degenerate or role playing dimension. One dimension resulting in other additional cube dimensions. We call role playing. There is something called degenerate dimension. These database dimensions can split into multiple other dimensions like product into subcategory, category, etc. A to B, B to C. Role playing means split one database dimension to multiple cube dimensions. Degenerate is one database dimension split to multiple database dimensions again. Okay, multiple database dimensions. No cube dimensions are involved. That is called degenerate dimensions. From here we have the final synopsis. Tabular mode to be used mainly for simple, easy, user-friendly cube design. Mainly for smaller data sets in on-premise environment. Multi-dimensional mode for complex solutions with cube dimensions. Complex with say multi-level relations. For example, table to table, there is one to many or many to one relation. Better to go for multi-dimensional mode. Standard, linear, regular tabular relations, two-dimensional relations, then better to go for tabular mode. So total there are two different broad classifications. Simple environments, two-dimensional relations, go for tabular mode. If in case you have multiple relations between the tables, in such a case, and you don't want to miss any relation, in such a case, say for example, time date to order date, due date, ship date, etc. Then go for cube dimensions. With this information, we learned comparison between the modes, tabular mode and multidimensional mode. And we also learned when to go for which. With this, we'll stop for now. You'll practice all items carefully and use me for doubts and clarifications. So make sure you complete all the practice part. And this is all about the SSAS concepts. Kindly complete all practice thoroughly before you proceed for the next module. Thank you very much. Have a nice time. Please practice. Thank you.